All right, folks. We just covered the first page. It's blank over here, but yeah, we talked about three conditions that should be true, must be true in order for a function g of x to be continuous at x equals to 8, right? So, yeah, welcome back to this lecture video. We are going to go over the rest of the handout number 6. And thank you for being understanding and being on the pace with me here so that we can get ready for our AP exam. I know you folks can do it, so let's work it out. All right. So here, for the graph of the function g of x, picture below has several x values at which the function is not continuous, right? So there might be a hole or there might be vertical asymptotes and all that, right? For each of the following x values, use a three-part definition of continuity to determine if the function is continuous or not. So again, we have to check, in nutshell, we have to check g of a defined, right? So that should be satisfied. We also have to check out limit of g of x as x approaches a. So left-hand side limit and right-hand side limit, we need to check that out. And then a third condition, the ultimate condition that needs to be satisfied was the limit of g of x as x approaches a should be actually the same as g of a. Right? So that's the three condition for continuity. So here, if it violates even one of them, okay, 1, 2, 3, then you can just make a conclusion that, oh, this function is not continuous at x equals to, for example, -8, right? Or x equals to 8. Right? Let's check it out here. I mean, graphically speaking, we already kind of see that there's a hole there. So with the graph, if I can go through that point, right, without any interference, right, or I shouldn't say we go through, I should really say trace the point, and then we're going through that point though. But here I actually have to stop and then draw a hole and then also there is actually interference, right? So we know that in that type of like informal way of figuring out whether there's a discontinued or not, we know it is discontinuous. But how do we actually use this definition to figure it out? So this is what you do. First, we'll check, is g of a defined? So you say g of -8. Does that exist? Yes, it does exist. Let's see, g of -8. We have a point over there, right? Which will give me y value of 4, right? G of -8 is 4. So it is defined. So it satisfies the first condition, for example, right? And then second part, let's try to find the limit. Limit of g of x as x approaches -8. So this means you need to find left-hand side limit and right-hand side limit, right? So limit of g of x as x approaches -8 from left-hand side, what's that going to equal to? Let me rewrite that limit. And then you will see that it is from left-hand side, it is approaching that point, which gives you -5, right? Also, you'll see that limit of g of x as x approaches -8 from right-hand side will be approaching the same hole right there, right? Which gives you -5. So guess what? Limit does exist, which is equal to -5, right? We satisfy the second condition. Let's check the third condition, which is the last condition to check it out. So we need to satisfy that limit value should equal to that defined value. And guess what? Here, limit of g of x as x approaches negative 8 is not equal to g of negative 8, right? So it does not satisfy that condition. So even though it satisfied the first two conditions, since it didn't satisfy the third condition, you're going to say, therefore, g of x is not continuous at x equals to negative 8. Pretty cool, eh? All right, let's check it for 2 here. We're saying negative 6, right? So as it is, our function continues at x equals negative 6. So take a guess right now, just by looking at the graph. Do you think it's going to be continuous or not? Is it going to be this point, right? Negative 6 and negative 7. And yes, as we're tracing and then going through that point, I'm not getting interfered with anything, right? I can just keep going like that. So yes, it is continuous. But how do we prove it? That means it satisfies all these 3 conditions, right? So here, using a definition, first of all, g of negative 6 is equal to negative 7. Second portion, limit of g of x as x approaches negative 6. What is that going to equal to? Left-hand side limit goes to negative 7. Right-hand side limit goes to negative 7 as well. Right, so here, it's a limit of g of x as x approaches negative 6 from left-hand side is equal to negative 7. Also, you know that limit of g of x as x approaches negative 6 from right-hand side is equal to negative 7. It seems like, can we already know that? Can we not just say that limit goes to negative 7? So for your test, they do want you to actually formally prove that this actually does work, that limit does exist. And using a limit exists theorem, yes, you do have to write down that whole thing, even though in your head you already know the limit of g of x as x approaches negative 6 is equal to negative 7. Okay, so get used to that. And the last condition is you need to say the limit of g of x as x approaches negative 6 should be same as g of negative 6. And, oh, guess what? Those are actually same value, right? Negative 7 and negative 7. So in this case, limit of g of x as x approaches negative 6 is equal to g of negative 6, which is actually equal to negative 7, right? So here, and instead of therefore, now I'm going to start using a mathematical notation. So instead of saying therefore, mathematicians usually use this 3 dots like that. So therefore, g of x is continuous. Okay, continuous at x equals to negative 6. Like that. And then this last part that I want you to try it on your own. This is when we're talking about x equals to, well, actually it's negative 4, right? So we're talking about that point there, right? X equals negative 4. So why don't you try that out on your own for, I don't know, 2 minutes. So pause the video for like 2 minutes or 1 minute, depending on how fast you can do it. And then let me know. Yeah. Okay. So here, what do you have? Is it continuous or not continuous? And it is going to be not continuous. By the way, you can interchangeably use it, not continuous or discontinuous. So here, first condition, let's see, does get satisfied. It says g of -4 actually does exist. It's that point right there that tells us the defined y value, right? All right, so checklist for that one. Number 2, what about limit? Limit of g of x as x approaches -4. Does that exist? And from our practices, we already know that this is going to -5, and then that's going to -2, right? So I know, again, it might be some of you folks might think it's too much work, but get used to that formal way of writing that down. So you say limit of g of x as x approaches -4 from the left-hand side will be equal to -5, whereas limit of g of x as x approaches -4 from the right-hand side will equal to -2. And then they're not equal to each other, which means limit does not exist. So here you said limit does not exist because of this, right? If you want to be a little bit more formal, you have to actually say because of these two conditions, right? Left-hand side limit and the right-hand side limit is not equal to each other. So, you know what? Let's actually do that. -4 not equal to limit of g of x approaches -4 from right-hand side. Then you say the fancy language, fancy mathematical notation that you just learned, or some of you folks probably already know. Therefore, limit of g of x as x approaches -4 does not exist by limit existence theorem. Little extra, right? That's more formal. Oh, okay. So does that mean do we have to continue with this guy? You don't have to continue because, first step, I mean, not first step, but the first condition got met, but then the second condition was not satisfied. So we right off the bat, we can say, so therefore, g of x is not continuous at x equals -4. So we can make that conclusion. Even though we don't have, we didn't check the third one, we don't have to, right? Because if it fails one part of the definition, you cannot jump to that conclusion right away. So at this point of time, some of you folks might be asking, so Mr. Kim, then do I really have to find g of -4 in this case? Like, do I have to see if it's defined? Can I just jump to number 2 and see that if limit does not exist, can I just say can I just make this conclusion here? You're absolutely correct if you're asking that question. You don't really have to go step by. Regarding 1 and 2, you could try 2 first, and then 1. Of course, third one actually comes after you get 1 and 2. So we cannot do the third one first, unfortunately. But which one you do it first, it doesn't really matter. First one or second one. So I could have just started with limit first and then limit does not exist, and hey, end of the story. g of x is not continuous at x equals negative 4 right off the bat. All right, so let's look at the next one here. Use a three-part definition of continuity to determine if the given functions are continuous at the indicated value of x. So here we're looking at the f of x, and then is f of x continuous at x equals to negative 2. So now graph is not given, but we have a algebraic equation that's given, right? Of course, we can use decimals to graph that out. And I'll show you how you can do that too, just to give you some little bit of more clarity. But for now, let's check this out. So negative 2, if you want to really like kind of look at this function over here, at negative 2, the actual function value is going to follow 3x plus 2. The left-hand side of it is going to be following this rule, right? Left-hand side, left of negative 2. And right of negative 2 will follow this rule, e to the x plus cosine of pi x, right? Okay, this sort of helps us out here, right? So first of all, we need to see three-part definition to see if it's continuous at negative 2. Is there a hole, or is there a we can trace the graph through it without any interference, or is there a vertical asymptote? We're gonna check that out. First of all, we know it's not vertical asymptote because it is defined. This function is defined when x equals negative 2. So first of all, f of negative 2, we have to use this function because when x is equal to negative 2, it follows that equation or function. So here, then you do 3 times negative 2 plus 2, which gives you negative 6 plus 2, so negative 4. So it is defined, right, to be negative 4. You got to find the limit value. So if you want to find the limit value, so limit of f of x as x approaches negative 2. What do we have to find? Always, if you want to find the limit, whether the limit exists or not, especially with a piecewise function, what do you have to check? Definitely have to check the left-hand side limit, and then you also have to check the right-hand side limit. Yeah. All right, so what's the left-hand side limit going to be? Limit of f of x as x approaches negative 2 from left-hand side. We have to follow that rule, so that we limit up negative 2 times square root of x plus 6 as x approaches negative 2 from left-hand side. Then you do a direct substitution, which will give you negative 2. So you're substituting negative 2, the x, negative 2 plus 6, so negative 2 times square root of 4. Square root of 4 is 2, so we get negative 4 over there. Okay. Probably good news, right? Negative 4, so far, but we really have to check our right-hand side limit as well. So here, limit up f of x as x approaches negative 2 from right-hand side. Then I follow the limit up e to the x plus cosine of pi x. Ooh. Already you're like, I don't want to deal with that, huh? It's not so bad. I mean, it's not so bad. You have that, and then you do a direct substitution. Over here, you're going to get e to the negative second power. So that's a number, right? Like 2.7, blah, blah, to the negative second power. Plus cosine of negative 2 pi. And cosine of negative 2 pi, if you're creating that again, right? 0, and then pi over 2, pi, 3 pi over 2. So, and then 2 pi. We know it repeats every 2 pi, right? The whole unit circle. And you'll see that what it means by negative 2 pi is basically you're, instead of going counterclockwise, you're actually going clockwise rotation. That you actually end up at the same point because you're basically going 2 pi clockwise rotation, right? Which is 360 degrees, so you will end up at the same location. And x coordinate has to do with cosine of that rotation, the angular rotation, and then y has to do with sine of that angular rotation. So here cosine, right? So guess what? That's going to be 1. So right now you have e to the negative second plus 1. And then that doesn't really, seems like it's going to be equal to negative 4, right? You can also rewrite this as 1 over e to the second plus 1. That is still a number. We cannot simplify further. We can write it differently, but there's really no point to it. And you see that those two are not equal to each other, right? So guess what? Since limit of f of x as x approaches negative 2 from left hand side is not equal to limit of f of x as x approaches negative 2 from right hand side, then or therefore we can say or then limit of f of x as x approaches negative 2 does not exist. This does not exist. And from there, we can make a conclusion that, therefore, it doesn't satisfy the second condition, right? So, therefore, f of x is not continuous at x equals to negative 2. I have to start a class soon, so let me pause for a second. All right, so let me continue this recording. I was just teaching a course. I'm just back right now. You wouldn't notice because I was pausing the recording. Okay, so let's try the next problem here. So the nutshell here is, if you look at this problem number 4, even though this function was defined at x equals negative 2, since the limit does not exist as x approaches negative 2, limit of function, and we know right off the bat this f of x is not continuous at x equals to negative 2. We don't even have to go to the third step, basically. Okay. How about the next one? Let's see. This one requires a little bit more work and our knowledge of whatchamacallit. Oh yeah, we need to know how to work with unit circle over there. So let's work this thing out. Checking whether it is g of x is continuous at x equals to pi, right? So how do we check it? The first thing to check is g of pi, does that exist? I mean, shouldn't say exist, is it defined, right? And to find g of pi, because here we have to look at the interval. This function we're talking about x equals to pi, we're using e to the x times cosine of x, right? So what we're saying is, left of this, not including the point x equals to pi, we're using that function. The right side of it, we're using e to the x times tangent of 3x over 4. Okay. And here, with this guy, we're actually including this. And then with this function, we're not including pi over. So g of pi, then, in order to see which function we're going to use, we actually have to use that one because that's where the x value is included, the interval is included. X is greater than or equal to pi. So g of pi here, and you have e to the pi times tangent of 3 pi over 4 over there, right? And tangent of 3 pi over 4, how do you find that? Again, unit circle here. I erased the other one, the previous one here. It was 1, 0, 0, 1, right? And then there's going to be negative 1, 0, 0, negative 1. That might help us out. However, here's a problem that we might have. What's the problem we have is we're dealing with 3 pi over 4, which is not pi over 2 pi and 3 pi over 2. So we're not talking about those 2 points, right? Well, where's 3 pi over 4 located? So in terms of a degree, 3 pi over 4 is actually equal to 135 degree rotation. So we're talking about we go beyond 90 degrees, then we stop over here, 45 degree more, right? So we're actually talking about that coordinate over there. So what is that coordinate going to be? In order to figure it out, I need to actually draw a right triangle over here, right? And with a 45 degree more here, right? Or pi over 4 more. The total angle that actually moved was, that portion is actually 3 pi over 4. Again, if you do not know unit circling and all that, I'll create a video for you to work on. Meanwhile, you can work on the Khan Academy link that I sent you. But yeah, 3 pi over 4. So in order to find that coordinate here, you need to look at 45, 45. '90 right triangle. And since we know this is going to be 1, the radius is 1, right? The ratio that you're, the side that you're going to get is radical 2 over 2 and then radical 2 over 2. So you either memorize that or you can derive it actually. That means the coordinate over here is, in terms of x coordinate, because I'm going to the left by 2 radical 2, that'll be negative radical 2 over 2. And then in terms of a y coordinate, I'm actually going up by radical 2 over 2. So that'll be that. You see that? So my tangent, by the way, I told you, there's a lot of things going on here, right? Tangent is sine over cosine, or y coordinate over x coordinate in the unit circle. So that's actually tangent of 3 pi over 4. Instead of writing it down here, because we might need a space later on, I'm gonna write it down over here. Hello, I'll be right with you, 6th period. I'm recording something right now. Tangent of 3 pi over 4. That'll be actually equal to radical 2 over 2 over negative radical 2 over 2. And you see the same expression here. So you're actually going to get 1 over negative 1 if you simplify it, which is negative 1. So here, that whole thing, tangent of 3 pi over 4 is actually negative 1. So there will be e to the pi, that's a number, right? which is equal to negative e to the pi. So that's defined. G of pi is defined, which is negative e to the pi. All right, I'm gonna start addressing my 6th period students. So I'm going to stop and pause this recording for a second. All right, folks, let me resume my work here. Let's see where I left off. Okay, number 2. I just have to find the flow here. Okay, so we figured out that that was negative e to the pi, right? That's the number. That's defined there. And the next thing is, does the limit of g of x as x approach pi, does it exist? Right? So what do we have to figure out again in order to figure out if it exists? Yes, you folks are right. We need to find out the left-hand side limit. And then we also have to figure out right-hand side limit. Pi. Right. So from left-hand side limit, what equation are we using? We're using this guy, right? Oh, see, this is what happens when I come back. So left-hand side of this pi, you're using that one, right? If I use the same analogy as this one, so we're using this guy here, right? Left of pi, and then you have to use, for the right side, you have to use this guy. Okay, so here the limit of e to the x times cosine of x as x goes to pi, that should be e to the pi times cosine of pi. And what is cosine of pi? Pi is 180 degree, and then you look at it, that'll be, oh, negative 1. So guess what? You get negative 1 times e to the pi, so which gives you negative e to the pi. Oh, we have a good feeling, maybe. But we had a good feeling over here too. Remember, we got 4 here, negative 4 here. But then here we got some goofy guy, right? As long as this is also negative e to the pi, maybe we'll work it out. But here, we actually did the work for this one already. E to the x tangent of 3x over 4 as x approaches pi from right-hand side. You do a direct substitution. It's going to be actually the same thing as finding the defined value there, right? So here it will be e to the pi times tangent of 3 pi over 4, which will be same answer, negative e to the pi. Oh, awesome. So that means since left-hand side limit and right-hand side limit are equal to each other, right? We know that it has to equal to negative e to the pi. So limit does exist. Not only does it exist, but also will show that. Oh, there's not enough space here, huh? Number 3, so first one checks out, second one checks out, right? Limit does exist, and then it's defined. And I jumped to the conclusion already because I got too excited. But you see that, oh, they're actually equal to each other. So that means our third condition, the limit of g of x as x approaches pi, actually is equal to g to the pi, because both of them are equal to negative e to the pi, right? So therefore, you're saying g of x, my g of x is continuous at x equals to pi. So for this case, number 4, it was not continuous, right? The f of x was not continuous at x equals to negative 2 because he failed at the second condition already, right? But here, for number 5, it satisfies all 3 conditions. So we know that g of x has to be continuous at x equals to y. All right, let's do number 6. And number 7 is a little challenging. I want you to actually try it out yourself and then work it out. Number 6, this type of question comes out a lot in AP exam. I mean, number 7 too, something free response questions. This is not too bad actually. You can work this thing out, but let's start off with number 6. The idea itself is the same, just the calculation itself could be a little daunting. All right, consider the function f of x to the right to answer the following question. So we do have a piecewise function. So you can kind of think about this before you draw anything. Maybe like there's a -1, then 3. So there might be a disconnect, right? Or it might be continuous. We gotta figure it out. So here, left of -1, the function is 2, and then right side of the x equals to 3, which is -2, right? Okay. And here we need to figure out what mx plus k is. Should I use a different one? Yeah, why not? So I have mx plus k between -1 and 3. So what two limits must equal in order for f of x to be continuous at x equals to -1, right? So graphically speaking, by the way, this means, oh, sounds surprising, my face just popped up. It goes something like this, right? So we're saying when x is less than -1, the function is y equals to 2, right? It is always equal to 2 regardless of the x value. And when x is greater than or equal to 3, we see that it's always equal to -2. That's what we have for our function here. And then I created something like this. So between -1 and 3, the function that we have is mx plus k, which is a linear function. But depending on how I change k values, right? Is translation there, and then how I change the m value, it changes the slope. But I'm gonna do it until I can make this work, right? That it'll be continuous somehow. Even before actually going over it algebraically, the answer is actually going to be this. Ooh. Ain't that pretty cool? When m is equal to -1 and k is equal to 1, you see that it is continuous at -1 and is continuous at 3. Right. So I want you folks to see the connection right there. Ain't that pretty cool? Of course, we don't want to do a guessing work just like we did here, even though it's pretty cool to see how we can connect those two. I mean, how can we make it continuous at x equals to -1 and then x equals to 3, right? So how do we work this thing out? So what two limits must equal in order for f of x to be continuous at x equals to -1? You know the answer to that. For limit to equal, right, to be continuous there, basically the left-hand side limit, right? Limit of f of x as x approaches -1 from left-hand side should equal to the limit of f of x as x approaches -1 from right-hand side. That was our second condition, right? I mean, we established that it is already defined at x equals to -1. It's equal to 2, actually, right? So the second condition should be limit should exist. That means left-hand side limit and right-hand side limit should be equal to each other, right? And they should actually equal to 2. to be more specific, because to satisfy the third condition, right? Which is limit of f of x as x approaches -1 should equal to f of -1, which in this case is 2. B asks, what two limits must equal in order for f of x to be continuous at x equals to 3? So that means similar. You're going to say limit of f of x as x approaches 3 from left-hand side should equal to limit of f of x as x approaches 3 from right-hand side. So based on this, that will actually help me figure out what the mn and k is. Okay. Even though we were able to find it somehow, just playing with it in the Desmos, we found that m and k, but that's just lucky work. And actually, I knew the answer, so actually, as you saw, I set the m as, was it -1, and the k is 1. But how do we actually figure out? Systems of equation, if you're not used to it, you probably have to review that too. Because there are two variables that we need to figure out, m and k. And that means we need two equations, at least two equations to figure out what m and k is. So how do we figure that out? Well, we have this condition to satisfy, and that condition to satisfy that this function is continuous everywhere. So not only continuous in -1, but it's continuous at x equals to 3 too, right? So that means, graphically speaking, they should meet up here, defined here, like that, right? So how do you figure this equation of that guy, right? So this is what I do. The first case, let me call this a first case, and let me call this a second case. So first case here, limit up f of x as x equals to -1 should equal to f of x. That right? Oh, you know what? Let me actually. Sorry, folks. Just erase that. But let's be a little bit more formal. So continuous means it has to satisfy all these three conditions, right? So not only the limit does exist, but we have to add something else here. It should actually equal to f of -1 in this case. And in this case, it would be f of 3, right? So I'll say, to be specific, number one case is continuous. So f of x continues at x equals to -1. So if I want to do a full work here, that'll be, first of all, f of -1 defined. It is defined when f is -1 is equal to 2. And the second portion is I need to find the limit, right? The limit of f of x as x approaches -1 from left-hand side, and the limit of f of x as x approaches -1 from right-hand side. And that should equal to each other. Well, I mean, let's go step by step. So they should equal to each other to have the limit to exist as x approaches -1, right? So what is this? Then you get limit of 2 as x approaches -1 from left-hand side should equal to limit of right-hand side of -1, mx plus k, right? Mx plus k as x approaches -1 from right-hand side. When you substitute for -1 in x here, now this is what you get. The left-hand side becomes 2, right? So 2 is equal to -1, substitute here, that would be -m plus k. So I don't know what m and k is yet, but I know -m plus k should equal to 2 in order to satisfy this condition. And this automatically tells us that it's going to equal to each other. So 3, as long as we can figure out what the m and k is, that satisfy is equal to 2, then we can actually establish the limit of f of x, so x approaches -1. Because if we're saying this is equal to 2, then it should equal to 2, right? Is equal to f of -1, which is equal to 2. Then we can say that if you satisfy all these 3 conditions, right? So I already told you we might have to use a systems equation. So we have one of this guy here, but that's not the end of it. Second equation that will help us figure out m and k will be this guy. So number 2 here is now f of x, case for continuous at x equals to 3. So first case, what is f of 3? X greater than or equal to 3, you get -2. So actually f of 3 is going to be -2. And then second case, so it's defined there. And then my limit value as x approaches 3 from left hand side should equal to limit of f of x as x approaches 3 from right hand side. Left hand side we gotta use, so left hand side of 3 we gotta use mx plus k, right? There. So right now we're using mx plus k, limit of that as x approaches 3 from left hand side should equal to let me see, where is this guy? Limit of -2 is right hand side, right? As x approaches 3 from right hand side. And guess what that gets us is, let me move this a little bit. And that whole thing is when you substitute for 3, direct substitution, in the x, then you get m times 3 plus k, or 3m plus k, right? Should equal to limit of -2 as x approaches 3 will be just simply -2. Also, we have another equation set up here, which is going to be 3m plus k should equal to -2. Yeah. And of course, the third condition that needs to satisfy is our limit of f of x as x approaches 3 should equal to f of 3, which is equal to -2. This will satisfy because we already see that right hand side limit is -2. So as long as 3m plus k is -2, we will be satisfied that limit of f of x as x approaches 3 will be -2. So how are those 2 equations going to help us out to figure out the m and k? We already know m has to be -1 and k equals to 1 from our decimals. But how do we do this using the system's equation? Is now we have -m plus k is equal to 2, right? And then you have 3m plus k is equal to -2, right? Then, I mean, you can do elimination, substitution and all that. So choose your cup of tea, I guess. But here, what I'll do is I will just subtract that guy. So what happened to get rid of the k, basically, right? So when I do that, just be careful. So there will be -m. You have to do the distribution properly. -m minus 3m gives me -4m, right? Or you know what? I don't want to confuse you. So why don't we just multiply everything over here by -1 and then work it out? Then you have a new system's equation modified as -m plus k, distributed to every one of them. Then you get -3m minus k is equal to 2. That's probably better for to reduce your error, right? And then from here, This is called elimination process, right? K minus K gives me 0. That gives me negative 4m, right? And then gives me 4. Oh, so we're saying negative 4m has to equal to 4, which gives me m is equal to negative 1. Cool beans, right? That's how we figure it out. I mean, we already know m is equal to negative 4 from that decimals. How do you figure out the k? You can substitute for that in one of the equation and figure out for the k. Let's just try that in over there. That'd be negative of negative 1, right? Plus k is equal to 2, which will give me 1 plus k is equal to 2, which will make k equals to 1. Aha! So we found our m value and k value here. So the final answer is going to be that m is equal to, what was it, negative 1, and k is equal to 1. Now let's go back to our graph over there. Where's the graph at? And then if I change the negative m to be negative 1, and then k to be 1, hey, ain't that pretty cool? We can visually see, graphically see that this function becomes continuous right there. I don't have any interference as I'm actually going through it, as we're going through each of this sort of a piecewise breakpoints, right? All right, so that is it for number 6. Number 7, I want you to give it a try. I'm gonna give you an answer for it. So I created a graph for this one too. So number 7, it looks something like this, right? Same thing, just slightly harder because it will be dealing with a lot of like crazy rational numbers, not nice number, negative 1 and 1. But same idea goes from number 6 to number 7. The main thing is you gotta find the k and m, and here k value will equal to, I wrote it down somewhere, or actually you can just take a look at it here. K is going to be 7 over 6, or 6 over 7, sorry. And then m is going to be negative 73 over 7. Not a nice number like 1 and negative 1, eh? And guess what? Of course, you could have guessed it using, just do m and k over here, but that will take a whole lot of time, even more than the previous one. Who would have guessed 6 over 7 and negative 73 over 7, right? But you'll see that the main takeaway here is you have a 3 piecewise function here, right? 1, 2, 3. This is apply for x is less than negative 2, and this is apply for x is greater than or equal to negative 2 and 3, less than or equal to 3, and then x is greater than 3. And you will see that, ooh, nice. It's continuous at each of those like piecewise breakpoints here. All right, so I want you to try yourself. I mean, I already gave you an answer, but how do we figure out 6 over 7 and negative 73 over 7? You'll be, after satisfying 2 particular conditions, right? F of x continues at x equals to negative 1, and f of x continues at negative 2, for example, for, f of continues at x equals to 3, you see that we came up with 2 particular equations, right? And then we needed to do a systems equation to figure out what m and k is. Since here they're asking for m and k again, right? You have to expect that you'll be given, and you will come up with 2 equations and do a systems equation, and we'll come up with the solutions. All right, impress me, try it, and let me know. And yeah, that will be all. And your homework, which is I'm assigning right now, is going to be this guy. continuity practice. It's not too long. It's due tomorrow 11 p.m. So first part 1 through 3 is basically, like, oh, is this function continuous at x equals -5? Use three-part definition to tell us if that's the case. And then here, use three-part definition of continuous to graphically justify why p of x is discontinuous at x equals to 0, which is this whole here, and x equals to 2. Looks like, graphically we can already see there's a disconnect there, right? But use a three-part definition to prove that, which means you have to tell us which of three definitions does it violate, right? Or does it not satisfy. Number 5 is similar to number 6 and 7. Here you might struggle with stuff like this, e to the ln 2x plus 3. But let me give you a hint here that 2 to the ln, e to the ln, let me just give you a hint here. If you're still watching this lecture video, is if you have e to the ln x, that's actually the same thing as x, right? E and ln, they're inverse of each other. So what happens is, or e to the ln 5 will be just simply equal to 5. So as long as that x is greater than or equal to 0, because that's just domain of ln, we know that e to the ln x is just simply equal to x. Okay. So that might be a little bit tough with that, but so here too, if I want to say e to the ln 2x plus 3, will be simply equal to actually 2x plus 3, as long as 2x plus 3 is greater than, it should be greater actually, sorry, not even 0, but greater than 0. Here too, I made a mistake. It should be greater than 0 actually. X is greater than 0. That's just a characteristics of log functions, where you cannot include domain that is equal to 0 or less than 0. So only talks about positive number. And then those, 6 and 7 should be straightforward. You can work this, and it'll be even more simpler than problems like number 5. All right, so try that out. Let me know how it goes and ask me questions, and you'll be good. All right, I'll conclude today's lecture. Good luck.